Okay, so it will change the flow profile. To overcome this problem, okay, so this is the problem. So you need to recommend a design that will lead to a more uniform section flow. What will you do? When you have the same section flow, the fluid feel that the wall is getting closer. So if you want to overcome that, you need to make diverge. How big? Very big. How big is big? How small is small? How handsome you are? We are engineer, we need to quantify anything. How big is big? Pretty big. For this condition, what is the size? You know the test section is 30 cm. Now, uniform across the flow, along the flow. So now if you want to make it like the apparent wall will not affect, you need to make it diverge. How big? Double. How do you know it is double? Yes. Right? So, you need to calculate this. This is your apparent wall thickness. So you need to add 1.83 millimeter on each side. Such that the flow field that the wall will remain flat, constant. Yeah? So how do you calculate this? Calculate Reynolds X, then you can calculate your delta star. Okay, any question about that? So you need to make it bigger because otherwise at the inlet it looks like this, at the outlet because of this delta it will look like the diameter is smaller. So if you want to maintain it, you need to make it a little bit bigger. Okay. So you can calculate that the velocity now is higher as compared to that, right? You're supposed to have 4 meters per second uniformly along the tunnel, but because of that apparent wall effect, you get 4.1 meters per second. So if you want to make it 4, you have to increase the area such that the velocity back to 4 meters per second. Okay? Any questions about that? So we end our boundary layer concept class, right? The next one will be the external flow. Okay, before you go. So we will explain this next week. Just to go through it. Okay? The question is, you know what is the weight of this thing when it flies? 500 tons, which means you can have 500 of mother elephant fly there using this wing. Elephant, not you. If you are only 50 kilogram, roughly 50 kilogram, so you have 1,000, just 50,000 ton. So 100,000 of them. Okay. So this thing, this big, how on earth this big fat aircraft can fly? Okay. How on earth this big fat, not ugly, this is aircraft can fly there? Okay. This is marvelous engineering. And then if next day you look the top bird, okay, on top of you, you may just worry about his popping, right? But if that bird pop to you, popping, nothing will happen to you. You just get the dirt. That's it. But the second bird popping on your head, you better pray. You know this bird? You know this bird? You know this one, right? Nighthawk. This is B2 bomber.
Oh, bomber.
Okay? If this thing popping on your head, even if the bomb is not exploding, you will still die. So you can see that we learn from Earth how we learn from nature how we do that. Okay? So next time you have this one on top of you, you can, okay, safe, nothing will happen. But this thing on top of you and if your country is not in good term with the owner of this bird, right? If your country is in a good term with the owner of the bird, it's okay. I mean you are in air show, right? But if it flies when you are not in a good term with them, pray. Okay, and then all those things we learn from nature. We develop the submarine based on dolphin. We learn from dolphin so much. That's why not only the shape of the submarine, also the technology used in submarine we learn from dolphin. Right? The sonar. We are using the sound. We are not using the radar. Radar will not work under the sea. Because those water is really good absorbing radar. So you do not use that. And this, I told you that the Burj Al Khalifa can bend. So we learn from those coconut tree. Okay? When the wind coming, it is not try to fight it. Just follow. Okay? If you watch the movie Tai Chi Master, same with the nature. Basically, you should not neglect this phenomenon. Okay? So we will learn all about it in next class.